This lesson, Making Decisions in C#. The objectives for this lesson are to learn the various types of if and else statements, to effectively use the switch statement, simplify simple if statements into a ternary operator, check for null values using two different null operators, control compilation using preprocessor directives, and create your own custom preprocessor directives. Let's start out with the if statement. Now, an if statement simply says if some condition is true, the condition must be enclosed in parentheses, then you execute some statement or statements. Now, a single statement of code within that if statement does not need to be enclosed in curly braces, but if you have multiple statements, it must be enclosed in the curly braces. Now, I would highly recommend you always use braces for any if statement. That way, if you need to add an additional one, the braces are already there and you won't forget. If you have an either or, you can use an if statement with an else clause. Now, same rules apply as for a single if statement. If you have a single statement after the if and a single statement after the else, no need to put in the braces. But again, I'm going to highly recommend that you do, whether you have one or many. It makes it easier to read, and you won't accidentally forget if you need to add a new statement in there where you only had one before, you now have two, and you forget the braces. That second one will not be a part of the if statement. So definitely enclose within braces, please. If you have multiple conditions to check, you can use an if, else statements. Same as normal if statements, we use the curly braces to enclose each one. So we have if condition, and if that condition is true, then we execute statements 1 and 2. Else if you have the second condition, if that evaluates to true, then you execute statements 3 or 4. If none of the first two conditions are true, then the else statement and statements 5 and 6 will be executed. Do you know why you should subscribe to YouTube channels? You'll get notifications when new videos appear. You'll get recommendations for related channels. It helps the channel grow, which allows me to create more videos for you. It helps attract others to my channel. Your like helps others find videos that are good. So please take the time to like and subscribe to my channel, Paul D. Sheriff. Let's take a look at if statements in C#. Let's take a look at a simple expression here where we're going to test something. So I'm going to do if, and then remember the expression has to go within parentheses after the if statement. If that's equal to an empty string, go ahead and do console.writeLine. Product name must be filled in. Now I can do this all in one line, because there's the line termination there. The if statement isn't really considered part of a line, it's considered as part of another block. So this is one block of code here. Now I can either keep it on the same line, or I can break it off onto a separate line. When I run this, we can see that we get product name must be filled in, just like we expect. As I mentioned, I much prefer to put the braces around this. And the reason I said is because if I ever wanted to add another line of code, like console.writeLine, another line. So this will work. However, if I had left off this but kept it indented, you might think that both of them are going to get displayed. And they are when it's like this, but watch what happens when I fill this in. Now you see we're getting that second one, even though that's not really what we intended, because what we really intended was to have it like this. So in this case, nothing should display at all. So that's why I said be very careful. I would always prefer to use the if statement here with the braces. In fact, if you use Visual Studio, where you type in the if and then hit tab, it automatically puts them both in for you. So that would be a much better way to always use Visual Studio to write that if statement for you. That way you never forget to put them in. Let's now take a look at adding an else statement. Again, you should always use the braces. So now in this case, when we run this, it'll say it's a valid product name. Because if this condition is true, it runs any statement or statements within these curly braces. Otherwise, it runs whatever is within these curly braces. Another example of if is using the else if. I've changed the code to declare a price as a decimal. I set it to $5.99. And then I have an if statement that checks to see if the price is less than 5. Else if price is less than 10. Else if price is less than 100. Now, if none of those match, nothing happens because I didn't put a final else in. The final else is completely optional. A ternary conditional operator is like combining an if and an else statement into a single statement or expression. It's useful if you need to pass the results of this operation to another method. You do some condition. If that evaluates to true, it returns whatever is immediately after the question mark and before the colon. If the condition evaluates to false, you return whatever is after the colon. So for example, let's add a decimal cost equals 0. I want to get the results of that and pass it to the console.writeLine. So I'm going to check to see cost is equal to 0. If that's true, return cost is 0. Else, which is the colon, cost is not 0. Let's take a look at how the ternary conditional operator works. On line 1, we declare a decimal cost equals 0.0m. We then do a console.writeLine on line 3, and here's the condition part, cost equals 0. If that evaluates to true, then the part after the question mark, cost is 0, is returned. Otherwise, the part after the colon is returned. Cost is not 0. Let's go ahead and run this, and we see cost is 0. If we change this to a non-zero, we get the else portion. So ternary operator, very powerful, very concise, kind of a neat operator to take advantage of. The switch statement in C# is very useful. You're going to use this in place of multiple if-else-if statements when you have a single expression or a single variable that returns a single result. Once you switch on that expression or variable, you list all the possible cases that that result could be. So you might have a case result 1 followed by a colon, and then you have either one or many statements that would be part of that result. And then you break, which means you leave the switch statement. Or if it doesn't match that first result, maybe it's going to match the case of the result 2. You then have a colon and then a set of statements. And then again, a break, which would leave the expression. And then optionally at the very end, you can have a default, which means if none of those above case statements matched the variable or the result of the expression, then we do whatever else we want to do. Let's take a look at a switch statement. On line 1, we declare decimal price, set it equal to $5.99. And now we're going to do a switch on price. So it's looking at that $5.99. It's going to compare it now against each case statement. So on line 4, case less than 5, which means is price less than 5? If it is, then we do a console.writeLine. Product is less than $5. Break, and then it goes out of the switch statement. If that case doesn't match, we do case less than 10. And if that matches, then it writes the console.writeLine, product is less than $10, and then breaks out. And then our final one, case is less than 100. Product is less than 100 and breaks out of there. So if we run this one, we get the product is less than $10, as we'd expect. Now we can also test equality. So you don't need to use the relational operators. We can check to see if something is exactly equal. So now it says product is less than 5. We probably could change this is equal to 5. But you get the idea. So you can compare using equality. You can use comparison operators. You can even do ranges. Look up the switch statement. There's a lot of powerful stuff here. I just wanted to give you a brief introduction to it at this time. Let's now take a look at a null conditional operator. I know this is an operator, but it kind of fits within this decision-making process. We only use the null conditional operator with nullable data types. So here you can see I've got a decimal cost and a decimal price that are both nullable. Now what we're doing then is in the console.write lines, we're doing cost question mark dot equal. So it says if cost is not null, go ahead and execute what is after the dot, which means that method. So anytime you see the question mark after a variable name, it means check to see if that's not null. And if it isn't, execute the method. Otherwise, just move on. It won't do anything with that line. So basically, the compiler is writing an if statement for you. Let's take a look at an example of a null conditional operator. So just like on the slide, we create a couple of nullable variables, cost and price. Notice that price is set to null, cost is equal to 0. Line 4, console.write line, cost question mark says if cost is null, skip that line. Otherwise, perform the equals method passing in a 0 to see if cost is equal to 0. Then it goes to line 5, console.write line, price question mark dot equals 0. Price is null, so it's going to skip that line. So if we run this, we only see the one value, true. And that means that cost is equal to 0. The second line did not execute. Let's now take a look at the null coalescing operator. So again, it's a decision. And it says if the variable is null, return whatever is on the right-hand expression. Otherwise, return what is on the left of this expression. Decimal question mark price equals null. Console.write line price question mark 0. In this case, it's going to return a 0 because price is equal to null. Let's take a look at this in Visual Studio and write the C# code. Line 1, decimal question mark price equals null. Console.write line price question mark 0. That's the null coalescing operator. So if price is null, it returns whatever is on the right-hand side. So it returns a 0. If I change this and I make this $1.99 and we run, we now see it comes out to be $1.99. So it returns what is on the left-hand side of that null coalescing operator. Another operator that helps us make decisions is the is operator. It determines whether or not a variable is of a certain type. So this returns true or false. So in this case, we've got a decimal price equals 5.99M. I made an object variable called value, which we normally wouldn't do this. Remember, we want to try to stay away from the object data type. But I'm going to put the price into that object value. Then we can test to see, hey, what's in that variable that's an object? Is it a decimal? Is it an integer? So we use value is decimal. Again, let's take a look at this in Visual Studio and actually run that C# code. So decimal price equals 5.99. Object value equals price. Console.write line value is decimal. It is a decimal. So again, if we were to remember the debugger, we can come out here to the margin, click in there, and when we run, we can now hover over value and see what the value is inside of there at this time. Now you can't tell what the data type is from here, but that's why we use that is operator. Another tool we can use to make decisions is preprocessor directives. Now these are built-in compiler constants. Some of them help us set what is going to happen within our code and how it compiles, such as #nullable. And others we can use to define our own constants like #define. Now all of these start with a #sign, so you'll know that they are preprocessor directives or things that change the way our code compiles. So we can do a #if, #else if, #else, #end if to control which versions of code get compiled based on some condition. Now there are some predefined symbols. Debug and trace are set to true when in debug mode, and trace you can turn off and on at the project level. You can then use that with the #if You can say #if debug, and then certain things would compile or not. Same thing with trace. Also, each version of .NET has their own compiler constants already built in and defined, and those are things like .NET Framework, .NET 4.8, .NET 4.7.2. So these are the different versions of the .NET Framework. They each have these constants defined. Then you have .NET Standard. There's a kind of a lightweight thing called the .NET Standard that also has their own framework symbols built in and defined. And then, of course, we have .NET Core. And it's just .NET, .NET 7_0, .NET 1_6, etc. Now, we also can then use that, like I mentioned, using these #if, #else, #endif, for instance. So here's an example of using the debug. So if we're compiling in debug mode, which we are when we just press the start button there in Visual Studio, we're then going to say if debug, then it would write out console.writeLine debug mode, else console.writeLine release mode. Let's take a look at some of these built-in conditional compilations. Here in the program.cs, I have written #if debug. Now, let's take a look here. So #if, and then if you look here, you'll see in uppercase these constants like debug, net, net 6.0, net 6.0 or greater. So all these things in uppercase are the things that you can use with the hash. So notice how line 2 is in the normal colors for Visual Studio because it's in part of debug mode. We can tell we're in debug mode right up here. And then the #else is if I wasn't in debug mode, then it would do console.writeLine release mode. Well, you can change that by going up here and choosing release. Now, when you do this, the debug is no longer defined. Now, how do we figure out where those are defined? Actually, let's just run this first. So there's release mode. Change it back to debug. There's now debug mode. But how do we know which one of these are defined? Well, as I said, you can do it through the IntelliSense in Visual Studio. Okay, so you just start typing or hit Control Spacebar and it'll bring up the list. The other way, to put this back to where it was, debug, is right mouse click on the project, go down to the very bottom and choose Properties. Then underneath Build, General, you'll see right here now we have the conditional compilation symbols. Now you can add your own in the text box right here, but you can see the ones that are now defined for debug and which ones are defined for release. Notice that within the debug one, there's the debug symbol, and within release, there is the release symbol. So those are built in. Those are the predefined constants that Microsoft gives us as part of this Visual Studio environment, but you can obviously add on additional ones as well, which I'm going to talk about in the next section. We're not limited to what Microsoft has given us. We can add our own custom directives. You create them at the top of the file, must be the first line in the file, and we do not end them with a semicolon. You simply do #define and then you specify whatever name you want. Convention says to put them all uppercase. You can use underscores, that's fine. But no semicolon at the end. All this says is that this is defined. It's a true or false, that's it. So the #if says, is this particular token defined? Yes, it is, then console.writeLine US English, #else, console.writeLine other language. Now we can do it at the top of the file, but you can also do project-wide compiler constants. So you would go into those Project Properties Build tab, just like I showed you, and you'd enter the names again, only the name. Separate with a semicolon to define multiple constants. And again, convention says to do them all in uppercase. So let's take a look at doing file-level custom directives and global directives. So here's an example on line 1 where we do #define language_US. And now you can see on line 3 we test to see if that constant is defined, and if it is, on line 4 we will execute that code. Visual Studio tells us that the other code is not going to be executed. It does that by kind of graying all of that out. So if we run this, we'd see what we expect, the US English. If we just change the name of this, it no longer is defined, so the other else statement will now be displayed. Now we can also do the same thing. Let's just take that away right now. But if we go into the project properties, we go to build, and right here, put a semicolon and then do language _US. We've now defined it for any other files that are in this project. We haven't worked with any other ones here in C# fundamentals yet, but you can, imagine that there would be other files other than the program.cs, and we'll talk more about that when we get to building classes. Well, now you can see that it now picks it up on line 1, #if language US. Line 2, console.writeLine is the thing in the color coding, so that means that that constant is now defined for this, even though it isn't in this file, but it's done globally. In this lesson, we learned to always include braces with your if statements. We saw the use of the ternary operator for simple conditions. We saw the couple of different null operators for helping us check for null. And we saw the pre-processing directives that can help with versioning or making sure that certain code is included in the compile and certain ones are not. Coming up in our next lesson, do, while, for, and for each loops.